we just want to say a big welcome to everybody joining us on our Ekahau webinar series. In today's episode, we are going to be discussing everything related to Wi-Fi and education. I love the graphic here relating to somewhere quite close to our home over here in the UK. We're going to be talking about everything you need to know about things to design and optimize education networks, also how to configure education networks. And also we have a very special guest with us today that can actually debunk and answer a load of these myths around education in Wi-Fi. So, or Wi-Fi and education, should I say. So let me hand over to Matt and do a quick formal round of introductions, and then we can crack on with the show.
Of course. Thank you very much, Matthew. And by the way, in order to see Matt, since he's so tiny, I have to have him pinned on my third screen all the time throughout the webinar. So guys, it's Matt and Mark. We are directors of product marketing here at Ekahau, also running ECSE, which is our university courses and amazing training. And we are joined by amazing sidekick Stu from Too Awesome, a sales engineer from America. But our special guest and the star of the show today is Troy Martin, legend, ECSE trainer, and a good friend. So Troy, welcome. Thank you very much for joining. Thanks for donating your time. And why won't you introduce yourself very quickly?
Yeah, of course. Thanks for having me. So my name is Troy Martin. I work for a company, Trogan Consulting, where I do a mix of various services working with end customers or augmenting different partners' benches, acting as an advisor or mentoring their teams as they work on different wireless projects, or I work with manufacturers directly as they bring me into different engagements. As part of my practice, I've worked on several large universities and colleges or technical institutions across North America, as well as many K-12 school districts, including one of Canada's second largest school board, right, which consists of over 200 schools making up the district and upwards of 100,000 students and staff members within that organization. So all these different higher education institutions, K-12 schools have different requirements and different problems that they're trying to solve, even within the vertical of education.
All right. Well, it seems like you're in a great position to enlighten us and everybody else on the webinar, your experience from working in that field. So there's some of the things that we're going to be covering today in this webinar around Wi-Fi and education. Is one of the questions that comes up a lot is how often should I survey and optimize my network, which is a great question, and we're going to be answering that in a little bit more detail slightly later on in the show today, and we actually might have a question coming up about it very soon. But Troy, I see this question come up quite a lot when it comes to Wi-Fi in schools and universities, colleges, K-12, etc., etc. Do I need to install one AP per classroom? Maybe you can just talk to us a little bit about that statement.
Yeah, the question comes up a lot, and I've worked with a large number of schools that I would argue fall into the trap of thinking that they need one AP per classroom. And the reason they do that is they start off looking at it from a capacity perspective. And so they'll begin with the initial statement where they may assume that, you know, we're a pretty progressive school. We have adopted and embraced technology, and we want all of our students to use these devices. And to get a good experience as part of their learning progression through the schools, we want to guarantee that every student gets 8 megabits of throughput in the classroom, right? Which doesn't sound super high on its own. It's certainly not low. But if we start extrapolating these numbers out, 8 megabits per student, if you have a classroom that has about 30 students in each classroom, different schools have different sizes that can range anywhere from 15 to 40 schools in K-12 environments, or you could have hundreds or thousands of small classrooms as part of a larger campus. And when you start extrapolating that out and adding up all the bandwidth that each student needs, assuming that everyone needed 8 megs, you can quite easily exceed several gigs of capacity that's required for your network. Now, this becomes a salesperson's dream. They'll happily sell you the number of access points to deliver that capacity. But where it breaks down quite quickly is when it falls into the designers or the engineers' hands, trying to put together a solution that can manage that many access points, right? So if we run through the math where you need, 5, 10, 15 gigs of capacity, One of the questions I like to kind of reality check everybody is, if we look at just 5 gigs of capacity, that's a big number. We can certainly design Wi-Fi capacity to deliver 5 gigs worth of bandwidth, worth of throughput. But one of the questions I like to ask is, when we access the Wi-Fi network, where are the resources? Are they local to the school? Do you have all your data centers, your servers local to school? Have you centralized everything, right? So all of your WAN links are going back to a centralized server, or all the resources have you bought into the cloud, right? Are all the students accessing services on the cloud where they're going out to the internet, right? The point being that 5 gigs of Wi-Fi traffic that you're asking for, are you trying to send it over your internet pipe? And more often than not these days, the question is, well, yeah, all the resources are off-site, except for, sharing to a projector in a classroom or sending a job to a printer, but the bulk of the applications are off-site. And so when you start looking at that, okay, 5 gigs across your WAN link, here's an easy question: how big is your WAN connection? Right? And this is where a lot of schools, sometimes they like to brag and like, oh, we upgraded over the summer. We have a new link. It supports 500 megs or 1 gig of throughput, which is significantly lower than the capacity number that they just asked us to design for Wi-Fi. And so now there's a disconnect, right? You're asking for 5 gigs of Wi-Fi capacity, and you're trying to stuff that over a 500 meg link across your WAN connection, right? So now we have to backstep and actually look about what bandwidth will actually be used. And this kind of takes us away from the 1 AP per classroom approach, right? Which saves them some cost, less cabling runs, less APs going into the classroom, and you get a better overall Wi-Fi design. Now, this is on the classroom side, which is very different than looking at dormitoriums in university environments. There, you may be putting one AP into every dorm room. Often, if you're going with the hospitality type access points, where you're leveraging switch ports, you want some redundancy. You end up putting 1 AP in each dorm room. But leveraging Ekahau, you can put together a design where you may want to turn off many radios. Just because you're putting in an AP in every room doesn't mean you need to turn on every radio. The hardware is there for the wired interfaces, but based on your analysis and Ekahau of your design, you can figure out and optimize which APs are best turned off. And then if a student accidentally damages that access point, you can always remotely turn it on to provide extra coverage until you get a chance to send in a maintenance technician to replace or service that unit.
Yeah, that's a great bit of insight there. And you mentioned the hospitality APs for inside like dorm rooms, if you are going to do the one kind of AP per room in that example. And I just happen to have one to hand here. So you can kind of just see how these look a little bit different to typical access points that you would mount to the ceiling. So these are much smaller. They're usually that 2x2s. They're designed to go flat against the wall. They've got ports on the back to replace that kind of standard networking port that you would have in the room. And then on the bottom of the access point as well, you have lots of, well, I say lots, you've got like this one here, you've got 4 ports available, so you can connect things like TVs, phones, or other stuff in the room as well. So really great for those types of environments that you were just mentioning. We know another question as well that is going to come up today, that's quite a big one, is that how should people be configuring their education networks, and how is it slightly different to potentially other types of verticals? So I think we can probably tie that into one answer, perhaps, Troy, and we actually have some slides later on to talk you through about education network configuration and some of those other things that you need to think about as well.
Yeah, so fundamentally, when I think through the design process, in my opinion, there's nothing really different about education or a office environment or manufacturing in terms of the design process, right? That process that I'd follow remains the same across all those verticals. I want to spend a significant amount of time asking a lot of questions up front, right? Getting a lot of detail, gathering the requirements, so that when I start making decisions about my design, I don't have to make any assumptions. Right? Should I do this? Should I add an extra AP there? Do I spend the extra money to add this AP in this room? All those questions should have been answered by your requirements gathering exercise, so that you're not making assumptions. And for those partners out there, you don't want to be over designing the network, right? Design based on the requirements that were given. Don't add in extra hardware and price yourself out of the opportunity to win that project. Right now, if we look directly at education, there are some unique aspects as part of education. It's which kind of takes us up into the next point there on the slide, is it's sort of a microcosm of a whole bunch of special cases in Wi-Fi design, right? We have a large number of people, users that want to connect to the network. We have a mix of high density environments, especially in higher education, when you start moving into those large auditoriums. We have the dorm room environment, right? Which is one of the most challenging environments and hostile environments, I think, to provide Wi-Fi. They're extremely demanding users that expect the performance that they had at home, right? Where they just had one AP, very little channel contention. And when they start spending $10, $20, $40,000 a year in tuition, they expect great Wi-Fi in their dorm rooms as well, right? So it becomes a very hostile environment there. So trying to manage all these quite challenging environments across a single campus or a single deployment. And so that's where a lot of the challenges, I think, come in education.
Yeah, and we have a question that we actually wanted to pose to the audience today. So Mac, why don't you read it out whilst I launch the poll question?
Totally. I hope you have your closed captions turned on. So when is the ideal time for a college or university to survey and optimize the network? A, when the students come back from school. B, just before the exam time. C, during holiday season. D, when there is a change in the environment or requirements. Or E, all of the above.
And we will we see lots of people answering the poll question, so we'll just give everyone a little bit of time to answer these questions, and then what we will do is we'll actually dive deep into each one of these answers on the next slide to talk about some pros and cons of doing exactly that at those different times. So and then yeah, very interesting to see the results coming in. So what I'll do now is quickly end the poll question and then share the results so you can all see. So hopefully you can see on the screen now that the results of that poll question. So going from the top, then 10% people said that the best time is to do this when the students come back to school. Only 1% of you said that just before exam time. Okay,
I'm disappointed with this one, aren't you, Matt? Yeah, that would be fun.
Yeah, that'll be interesting to see if you still have that concept when we've spoken about that in a little bit more detail soon. During holiday season, quite popular. Then the second most popular was when there is a change in the environment or the requirements. That is a great and valid answer, but also a lot of you did say all of the above. So yeah, we kind of agree with that one there. So why don't we actually answer this in a little bit more detail then? So when is the most ideal time for us to go and survey and optimize our college or university education network? So the first one, Troy, then when the kids and stuff are coming back to school, why would this be a good time to do a survey and optimization of the network?
Yeah, so I think the back to school is it's a great time for new students coming into the education environment. A lot of times their parents are excited about sending little Johnny or Susie back to school. They want to equip them with the latest and greatest shiny new devices, right? So you see a lot of new devices hit the network that can put a lot of different capacity demands on the network, very different from the previous year of school. So new applications, new gaming consoles, new handheld devices, mobile phones, tablets that have different capabilities and requirements are hitting the school. So things can change quite quickly from year to year. So it's definitely a good time when students are coming back to school to figure out what's going on in your network.
So why then I know this one is what you spoke to us about the other day, Troy, when we was preparing for this, but you said exam time is a really key time actually when you might want to go and do the survey and optimization. So why is that?
Yeah, I think exam time is one of the special cases that you find in a Wi-Fi network. We talked a little bit about capacity requirements, which have their challenges for design, but there's something different about having students within an auditorium taking notes, doing some cloud syncs, checking emails, updating their TikTok feeds while they're in the classroom, and it's all intermittent use of the wireless network. What's different about exam time is everyone starts at the same time. When that bell rings and the exam starts, everyone hits go to interact with the exam writing system, and it's that synchronous access to the wireless network that places a big challenge on it. So optimizing your network for having everyone hit the network at the same time is critical for exams to be successful.
And then holidays periods, why would this be a great time to do that?
Very similar to the back to the schools after the holidays, particularly end of the year. You have that Christmas season. Everyone gets their or a lot of people get shiny new devices, and they bring net new devices onto the network come January, right? So you end up with a very similar repeat to the start of the school season. New devices with different configurations and capabilities will place different requirements on your network. They also may have brought in new versions of firmware that may be compatible or not compatible with the configuration you have on your wireless network. So definitely something to check out.
Yeah. And then finally, when there's a change of the environment or the requirements, I mean, this was one of the most popular answers. This is a key time that you need to be checking your environment if doing a survey and optimization. If you've had physical change, new devices coming in, different requirements, like Troy said, applications, devices. You want to ensure the network is optimized and ready for all these new devices, applications, the physical change in the environment. It is very key here. And the one pro tip we just wanted to end on this slide is that your environment actually changes all the time. So it's really key that you're regularly checking your environment and making sure it's optimized and performing well. And we can help you do that with Ekahau. So what we've done with our tools really recently is that we've made them so accessible and easy to use, but also really powerful. So now the data collection, you can just walk around with your mobile device connected to your Sidekick too. If you can walk a dog, you can walk a Sidekick. It's that easy to capture the data. Just have anyone walk the halls, campus, offices, whatever it is, collect that data. That data gets automatically synced, saved back up to Ekahau Insights, where our brand new feature optimizer that analyzes your network against your specific requirements and Wi-Fi best practices to give you that step-by-step guide of how to optimize your environment. And then you just rinse and repeat this as many times as you need to, like going back to the previous slide and the questions around your environment when you have the changes at different times, and you can just stay on top of things and make sure that your network is always optimized and high performing. And what Troy is actually going to do is give you a quick demo of this in action for a particular education network. So let me just stop my share, and then Troy, you can take over.
Okay. And what we have here is the Ekahau Insights interface, right? So I'm accessing my Ekahau projects from the cloud. We get a list of locations from various parts of the world that we worked on. And if I click on a project, which is just an example K-12 school, right? We can drill down into this and look at the different coverage on various floors. And it's Ekahau Insights just seems to be thinking hard for me for a moment here.
Yeah, typical, always the way. But lots of great questions coming into the chat as well today. So love seeing all of your audio comments. Keep them coming in. And yeah, back over to you, Troy, since you've got Insights and Optimizer ready to go.
Yeah, so you do have the ability within Insights to look at various heat maps, right? It's not the full set of heat maps that you'd see in AI Pro, but the ones that are highly relevant, and you can always share this with end users and customers. But what I wanted to call to attention is this optimizer feature, right? So after doing a survey of an existing school, we can come in here and we can get some feedback into the performance of that wireless network, right? So we can look at the coverage. If I click down on this, and Ekahau Optimizer is letting me know that the coverage, the primary coverage, is in good shape, right? All the areas on this floor that are in scope, nearly 100% of them have coverage. I get some commentary about what good Wi-Fi best practices are, some points that if I did need to improve anything, some suggestions on how we can do that. And if that wasn't enough, I have links to some Ekahau blogs that dive into some great detail to better understand why I want to make these optimizations in my network. So this was an example of something that was working well. My coverage and my SNR are scored well. I have some areas that there is room for improvement. And if I scroll down here to reduce channel interference, right, which is one of the big challenges, and the difference between just providing coverage on a floor or optimizing and delivering a Wi-Fi network that delivers the best performance, right? So here I can see on 2.4, it's very, very low, right? Which may be okay. Maybe I'm not designing for 2.4 gigahertz. I know all the devices coming into my networks will support 5 gigahertz. So I treat 2.4 as best effort, but I could probably do quite a bit better than 2%. or 11% on each floor. But I certainly should be able to improve the 5 gigahertz channel interference. And so again, I have best practices listed on the right-hand side, points on why I'd want to make those improvements and the benefit of making those changes. And if those little bullet points weren't enough, I can always check out the Ekahau blogs to get a lot of details on how these improvements will deliver better performance to my users for my schools.
Awesome. I'm going to steal the share back from you, Troy, so we can then, Mac, hand over to you, because gathering requirements is probably one of the key things to understand about any network, let alone education. So why is it so important, Mac?
Totally. So we already had a few questions about requirements, asking how many access points we would get for 500 students or stuff like that. And the answer always is it depends. And it depends on what these clients are doing. So if you have 500 students doing nothing with, phones in their pockets and every second person connected to Wi-Fi still not doing much, then maybe, I don't know, 5 APs will do. But if you have like the interactive class where everyone clicks on the link at the same time, if they are required, students are required to stream some stuff on their laptops or tablets, and everyone has a device in front of them during the lecture, then it's a completely different story. Then we need to start looking at high density design and potentially start looking at directional antennas. And actually, we have an amazing demo towards the end of the webinar. So Troy will talk us through these more advanced concepts about the requirements, capacity, and high density designs. So let's leave it there, but let's just have it on the back of our minds that it's very important to scope it right and cater for the capacity, because coverage is easy.
Yeah, I mean, so when you're speaking to your stakeholders or anyone about the wireless network, and you're asking about what client devices you need to ensure are connecting to the environment, isn't this the dream, right? Just beautiful, shiny new Apple devices that just come onto the network and they just work perfectly, no problem at all. Who here is excited for the new iPhone next week being announced? Is it going to have 6 gigahertz? We think it will. This is the dream, right? I mean, for us anyway, as you might know, a little bit of a Apple fanboys, but let's be honest, this isn't the reality about new devices always coming into our network. The reality is that, especially in an education network, we have to support older devices. We can't control exactly what devices are going to be coming into our network. Some devices are going to be really old. Some devices may even be 2.4 gigahertz only. So it's going to be very inconsistent. And there's a great quote here that I heard that says, the only thing you can consistently rely on is the inconsistency of the Wi-Fi client devices, which I don't think has ever been truer, especially in this.
Such a great quote, man. Can you shed some light on who has written this quote?
I must have seen it somewhere. I don't know, someone really inspiring. I guess I just saw it and I thought, this would make a great quote for the webinar. Maybe it was Troy. Who knows? So yeah, we have this concept as well that we talk about in our wireless training classes, ECSE and other parts as well, about the LCMI. So Mac, maybe you can just explain a little bit more about what that is.
Totally, absolutely. So guys, LCMI stands for least capable, most important device. So this is the device that must be working in a Wi-Fi network, but doesn't have the latest and greatest capabilities, most likely. So let's say in a warehouse, because it's an easy example, the LCMI least capable device might be a barcode scanner, and the barcode scanner sensitivity, receiving sensitivity, might be massively lower than a Sidekick or an iPhone or an iPad or a MacBook. For example, I'm talking Apple. I will have to stop. Then Samsung or Xiaomi, right? So LCMI in the office environment, your LCMI might be your mobile phone. In the university environment, you don't know. Okay, you don't know. So you will have students from multiple different countries. Every country has their own trends. You will have different devices supporting different things, different channels, different amendments. So when you get devices from China, for example, they might not be supporting all 5 gigahertz channels. If you have devices from Europe or from States, they will be supporting everything. But if you know that you have a fair share of devices that only support Uni1 on 5 gigahertz, it doesn't matter if you enable higher channels on 5 gigs, since these devices, they won't see them at all. So you need to understand what your devices are doing, understand the common denominator, the lowest common denominator of what all your devices support in your network, and then cater for those requirements. And also in the educational sector, you will have some IoT, weird things. Like we've had tons of stories from our friend Ferney, for example, where he was talking about wireless connected clocks on the walls, and they also need to be connected. And, you know, who knows what you have there in the university? You will have to check your logs. You will have to check if all your devices that try to connect, they can connect. And you will probably hear from students or from your IT team about the devices that can't connect to your network. So always have LCMI, least capable, most important device in mind while designing and optimizing your Wi-Fi network.
I remember sitting in on a ECSE design class, which Francois was teaching, and he said that when he was doing an education environment, he said one of the craziest devices that he had to get supported on the wireless network actually was a student had brought in a Wi-Fi connected lava lamp, and they was having issues with getting that connected. So that was quite a interesting device to get supported on the network. So now that we've discussed a little bit about the LCMI, we want to just talk through how you measure something that's called a device offset. And what that is when you've got two different devices where you're going to be measuring the difference in sensitivity between the devices so you can get kind of a baseline that difference. And what you'd be doing that with is if you've got one of our Psychic 2. So if you've never seen this device, this is our hardware device, our purpose-built measurement device that measures everything in Wi-Fi 2.4, 5, and 6 gigahertz. As well as scanning anything that's non-Wi-Fi in those bands as well that could be causing you non-Wi-Fi interference, being microwave ovens, passive infrared, etc., etc. But why it's important to understand what this device is, because this is the device that you're going to be using to do your site surveys with, is the Psychic 2. So once you've discussed with your stakeholder about what is this LCMI device, we have a few kind of recommendations for the getting the best measurements and accuracy for your device offset. So what you're going to do is you're going to take your Psychic 2 to a location, as well as with your LCMI agreed device. In this example here, we're using a scanner, but this could honestly be your corporate Windows laptop or your CEO's personal iPhone, whatever you decide it is. You get that device and you're going to take it to a location with the Psychic 2. And ideally, if you can, perhaps maybe get a couple of these LCMI devices. If not, don't worry, as long as you've got one, that we can work from that. And then what you're going to do is you're going to go to a specific location. So in this example here, we've got location 1, and you're going to be measuring the signals coming from one of these access points. And kind of the rule of thumb here is you want to make sure the access point is at least 4 or 5 meters away, and you've got kind of clear line of sight. You put both of the devices, so the Psychic 2 and the handheld scanner, in the same location. And what you're going to do is you're just going to look at the signals coming from the access point on the different devices. So in this example here in location 1, the Psychic can hear the access point at -50 dBm, and the scanners can hear it at -55 dBm. So what that gives you is a 5 dB difference between our Psychic 2 and the handheld scanner. And then what you might want to do is go to a couple of different locations and just repeat that process again to get that kind of differences between the devices in different locations, so you know what that device offset is going to be. So once you know what that device offset is, you can actually apply that to your project files in Ekahau. So this is what it would look like in Ekahau AI Pro. Once you've added, you can add the specific device profile. You can then assign the difference in the dB values, and then when you're taking a look at the signal strength visualizations, you can actually change it to be that specific device. But what I thought would be really cool is if we actually get Troy to give you a live demo of the LCMI and how you visualize that actually in Ekahau. So again, I'll just stop sharing so Troy can show you. And over to you, Troy.
Yeah, thanks, Matt. So here's an example of a school. And there's some questions that came up in the chat doing a survey. You can do a survey during the live school hours, or you can do it in the evenings. It just depends on what you're trying to measure. The signal strength coming from the access points themselves will be almost identical during school hours versus not. But if you're looking at active transmissions and how much traffic is on the network, that's obviously going to be different. Now, you can get permission to go into every school or into every classroom, which is what you see here. And you end up disrupting the classroom. So just a really quick story about that. And one of the reasons I'm using stop and go survey in this classroom, these classrooms were extremely dense, right? So the students didn't have any places to put their school bags or their school books. So they'd leave them in the aisles in between their desks. So whenever you walked into a classroom, it was very difficult to do a continuous survey and maintain a constant pace between clicks, right? Which is something of the best practice. You always want to maintain your same speed in between clicks, right? And also when you walk into classrooms, as a surveyor, you sort of have a superhero type effect. You open the door, you walk in with your tablets and your sidekick, and all the students turn their heads and their eyes look right at you, right? And they think that you are the coolest person out there. They all start thinking when they want to grow up, they want to be Wi-Fi engineers, and you're getting ready to motivate or inspire the next generation of wireless LAN pros, right? So you want to come into the classroom, look professional. You don't want to trip and stumble over anything. So in this particular school, I decided to do stop and goes where I can stand in one corner of the classroom, get a good position, and sort of instead of just clicking on the spot on the screen and twiddling my thumbs, I pretend I'm making important observations of the ceiling, where cables are, how the classroom is laid out, where the existing AP is mounted, nodding my head like I've made some important notes. And then I move to the next test location as I can hear the students talk to their friends going, what is he doing? Is he measuring the Wi-Fi? Is he going to make it better? And obviously we're there to try and improve things. But going back to the whole point of this demo, talking about device offsets, we can create a device profile. So under project devices, we have the ability to come in here and we can toggle between existing devices that are already pre-built into the AI profiles, or we can click on the add button and we can create new profiles. So I have an existing one that I've created called LCMI. I like using this name because I leverage a lot of custom report templates. And in my custom report templates, I modify the heat maps that are displayed when the report generates, and I can refer to this device profile to generate the heat map for this device. So in all of my projects, I use the generic name LCMI, but it allows me to minimize any changes into my customized report templates because they just refer to this name. You can choose whatever technology that client device supports, right? So to make it appropriate, choose the maximum channel width supported by that client device, and then define the number of spatial streams, right? We're seeing a lot of the Wi-Fi 6E or 6 gigahertz devices. They're gravitating towards 2x2 client chipsets, right? So you may want to choose that for the new iPhone that may be announced next week, right? And then based on the technique that Matt and Matt covered, you add your offset value, right? Which could be the same or it could be different for 2, 4, and 5. In this example, because I've selected a Wi-Fi 5 device, it does not support 6 gigahertz. But if I had selected a 6E capable client, I would have the option of adding a 6 gigahertz offset as well. So once I've created this device profile offset, I can close this and I can visualize my heat map. By default, you see the heat map for the measured device, right? Which will be our trusted and accurate Sidekick 2, collecting all the measurement data for us. There is an easy button that we can use called the View as Mobile Device button. This roughly applies a negative 10 dB offset pretty much across the board. It's the easy button, but we have no granularity with that. So if you want to apply the offset that I just created from my device profile, there's a hidden Easter egg. Now, a little pro secret, sometimes when I'm bored, if I'm on a plane or something like that, I like opening up AI Pro and I hold down the control or the command key and I just click on different buttons and I see what changes. There's a lot of hidden Easter eggs inside AI Pro. And one of them, if I hold down the command key on Mac or the control key on Windows, and then I click on these 3 dots in the bottom right-hand corner, if I actually click on the right button,
Are you hitting command button, Troy?
Yeah.
Always the case.
Yeah.
I
Live
think
demos,
sticky,
huh?
you got a sticky key, I think.
Apparently.
Is it?
This is so hard.
Try holding the option key.
Yeah, do you have a Windows machine, Troy?
No, it is a Mac. That is interesting.
Try reopening the file again.
Yeah, give that a go. All right, so I have downloaded this from the cloud, so I'll try open it again from the cloud. And we'll open K12, open from the cloud. So it'll just take a few moments here just to download it from the cloud. And there's other things. If you just another secret, if you click on the wall drawing icon, right? If you click on that, there's a little settings button across the top. If you click on settings while you're holding down the command key or the control key, you should also see some hidden Easter eggs, right? So this time it's working. Now that I've reopened it, if I hold down the command key, now instead of seeing view as mobile, I get a list of all of my device profiles that I can toggle through that exist within the project, and I can choose my LCMI device that I've created, right? And so when I apply that, now the heat map that I see has that 15 dB offset on 5 gigahertz. And if I flip to 2.4, it would display a 12 dB offset on the 2.4 band. And down here on my legend, I get a little reminder that I'm viewing the heat map from that device's perspective, right? So I know what I'm looking at. I don't get confused looking at the wrong thing.
Awesome. Thank you very much, Troy. I will steal the share back again so I can hand it back over to Mac, who's going to talk to us about some of the common challenges actually with Wi-Fi in education.
Where to start? So as you know, education sector is probably one of the most complicated and most, difficult, because people, they will complain and it never works because you can't predict your devices that are in your network. But if that's not enough of an issue, look at this. Building architecture can be a problem. Universities are getting crazy. My university was all concrete, for example. The previous one was like all glass and concrete and weird shape. This one is listed building, so it will have a 1 meter or 1.5 meters thick walls where nothing goes through. Maybe it's good if you get to the class and you have an access point in the class, but how about roaming? How do you tackle that? You leave the class, you close the massive wooden thick doors behind you, and then you dropped off from Wi-Fi. Or this guy here, this building must be like 1,000 years old. Who knows how thick the walls are? And if they are super thick, then it's very challenging to get a fast roaming. If the roaming is not a requirement, that's easy peasy lemon squeezy. But if it is, then it requires a know-how about how to design for this kind of environments. So yeah, it's never too simple with education.
Nope. And for sure, when you've got these types of environments, making sure that when you're doing your predictive modeling is you get it accurate as possible. So you can see here, we've got some common wall type of materials that you can use for your Ekahau AI Pro design files. But it's really important to make sure you get these accurate. So when you go on site, you get them measurements with a trusty sidekick too, and then you can come back to your Ekahau AI Pro and make sure you've got those updated values, because if, like Mac just said, if you've got a 1.5 meter thick brick walls or concrete, then that's going to cause even more attenuation than 10 or 12 dB. So you need to go and measure it and update your designs accordingly. So Troy, what are some other potential challenges when it comes to the education sector?
Yeah, depending on the era that the school was constructed in, you could have the aesthetics committee that plays a very large role in the regulating where you can place access points or mount antennas, right? You may not be able to run cable or conduit everywhere you need to place the AP in the best spot. And it's now your design needs to consider those aspects. Some people don't like the look of access points, right? So they want them to blend in. They think that they're an eyesore. I, for one, think access points are beautiful, and I get excited now that my kids can point them out when we walk through shopping malls or airports. They send me pictures of APs from their schools, that kind of thing. But other people don't want them to take away from the aesthetic ambiance that the architect was looking at when putting together those libraries or large auditoriums, working spaces, right? I often find that if the Wi-Fi is not working well at a particular school or campus environment, there's less focus on the aesthetic requirements. They just want it to work. But if people start taking Wi-Fi for granted, the requirements of the aesthetics committee creep in, become stronger and stronger requirements as part of your designs, right? And so there's lots of different partners that you can engage with that provide different enclosures and different options for ways that you can hide your access points to make them aesthetically pleasing while still delivering the Wi-Fi performance that you're trying to meet to deliver the design requirements. Outdoors can be challenging as well, right? Often there's light poles that you can use, very convenient if they already have networking cable run to them. A lot of campuses are thinking ahead and are running power and network drops to the light posts in anticipation of connecting networking equipment. Other times, maybe it takes some cable runs over the summer to get cabling to the access points themselves to provide your Cat6, Cat7 cables, right? There's also ballasts that you can mount access points in, right? So little posts that could go beside bike lockups or garbage cans. You can mount your access points there. But especially as you move further south across the globe, there's more time throughout the school year to spend study time outside, hanging out with friends, downloading notes or recordings from the professors, while you're still soaking in some of the sun rays, right? So outdoor campus spaces are becoming increasingly important to provide Wi-Fi coverage. And you definitely wanted to consider that as part of your Wi-Fi design plan.
And if you missed our last webinar, we had a amazing guest speaker from Ventev Dennis, and what Ventev do is they offer unique solutions for challenging environments. So a bit like what we just saw there, and Troy is mentioning, you know, some of the light poles might be where you can get cable into. Well, you can actually turn some of that street furniture into housing for your external antennas. So we've got some different options you can see here in the kind of like this ground option, and then we've got lightning post for lamp pole, what we can see here. So very unique different options that we can provide coverage for if we're struggling to run cables or get those kind of like mountain locations. So there's always a unique way that we can overcome any challenge. So if you didn't see that webinar on our last one, I highly recommend that you check it out. Mac, high density environments, when you've got beautiful aesthetic concerns in these auditoriums, what do we do here?
We have tons of options, and they are all amazing options. I would love to drop the access points down with the antennas being visible, because they are beautiful, right, to look at. So you're sitting in a massive theater hall, and you look at this access point and you feel, oh my gosh, this is such an amazing space, because I know that Wi-Fi is great here. But if you can't have that for some reasons, aesthetics, architectural reasons, you can't run cables on the ceiling, you have options. You can attach a piece to the walls and have directional antennas and point them in different locations, lighting up different areas of the high density area. So you have frequency reuse, and when you are moving around the big lecture hall or a town hall meeting or a stadium or whatever, you will be jumping between different access points. Different sections of the physical space will have people associated to different access points, to different radios, okay? So you can reuse frequency to the point where you have high capacity, and you can serve all this nice and funny people sitting down there in this luxurious chairs. And you can shoot from the bottom. You can install the access points under the seats. And when you when you survey the empty hall, then you might see a lot of CCI channel interference. But then when you have a lot of people sitting on those access points, actually, you will very quickly notice that the coverage cells from this AP is shooting from the bottom to the top. It's shrinking, and actually you have a nice frequency reuse. And also in stadiums, you can shoot to the sides from the rails. So depending on the environment, you have tons of options, and Troy will talk us through a 1 or 2 option in the open space area in a second.
Shooting from the bottom through the bottom causes some reduction in cell sizes, shall we say. So really interested to hear what Troy says about this, and how I can visualize it a little bit better about the capacity planning of your network when it comes to that exam time. So yeah, over to you, Troy.
Yeah, so in this the exam environment, it's rather challenging. A lot of schools that I've seen, they'll temporarily augment their auditoriums or the gymnasiums, wherever students are writing the exams, and they'll add additional access points. Again, there's a very different scenario when everyone at 9 o'clock in the morning, when the clock strikes 9, they all hit the go button and access the wireless network. It's not staggered access or bursty applications. It's everyone going at the same time. And you certainly don't want the scenario where the Wi-Fi network crashes while you have, hundreds or 1,000 students writing the exam all at the same time. And then with lecture halls, you have a lot of different options on how you can orientate and position the access points. Depending on when the lecture hall was made, it may be relatively easy to mount access points underneath the seats and run the cabling there. For older buildings that are poured with tons of concrete, or it's very difficult to run cabling through there, it's not cost effective to drill through all that concrete, right? So not only are you trying to create a design that propagates RF energy in ideal directions, you also need to appreciate the realities of business, right? There is a cost to where you place every access point. So your design should consider that. What's the most cost-effective design that still meets all of your Wi-Fi design requirements? And those are considerations that you need to look at when you're designing for these high-density lecture hall or theater type environments.
And I guess there's sometimes where the people doing the judging of the Wi-Fi in certain lecture halls is a little bit more in depth. So in this example here, we were actually presenting at a Wi-Fi conference called Wi-Fi Design Day in London, and we had tons of fabulous Wi-Fi engineers and Wi-Fi professionals in this room. So I think it was quite important that the Wi-Fi works well in here, because I think one or two people may have been checking that. But since we're on the topic of Wi-Fi conferences, we wanted to let you all know that you can now register for our upcoming Wi-Fi Day, which is our virtual event that is happening on the 5th of October. So if you want to sign up, save your seat, get registered nice and early, you can just scan that QR code or head over to ekahau.com/Wi-Fi Day 2023. Make sure you've got your seat reserved. We're going to have a fabulous virtual wireless conference for you, and we will be announcing some speakers and some really cool stuff very shortly. So Troy, you mentioned about how we potentially would design for those areas. Maybe you can actually give us a bit of a demo in Ekahau how you can design for high density and capacity in mind.
Yeah, absolutely. So now I'm feeling a little nervous with my demos. I feel like I'm 0 for 2, so hopefully this one goes a little bit smoother. What I wanted to show off here is a high density design with a few different options to kind of talk through the scenario that client devices would experience. So we have a bunch of different kind of typical classroom sized areas, and then we have this large auditorium, right? And what we can do is we can select an AP, and then for this example, I'm going to grab the MIST AP45 with integrated antennas. And if I just drop one of these access points into this auditorium, very quickly we can see in the heat map, one AP covers the entire auditorium, right? So we have roughly 300 seats. If the auditorium was filled with students, all paying their tuition bills, the campus would be quite happy. But one AP won't provide enough bandwidth for all the students if we have 300 students in there. But in these open space auditoriums, you want to be mindful that APs with integrated antennas cover the entire environment. And Apple has shared some of their roaming behavior details with us. And one of the parameters that Apple devices look at, particularly iOS devices, is they will not start scanning to look for another access point until they hit a -70 threshold. So if I walk into this auditorium and in between classroom changes, you start to get a collection of students that waits in the lobby area outside the classroom. If they had another access point up in this area here, they'd all be connected to it. When they walk into that classroom, if they don't hit an ECSE boundary, they may not even roam to the AP in the auditorium. If they do roam to the AP in the auditorium, there's a good chance they remain sticky to that access point. And if you added more APs to add capacity for your network, you may not get the benefit of clients roaming to other APs because of the inherent roaming behavior of your client devices. They prefer to connect to one AP. Client devices often view roaming as a risky behavior, right? Which can induce stickiness, right? But if we were able to control some of these access points and how they roamed and behaved, right? If I delete that AP, if I was able to swap out this AP, and let's grab a MIST AP45E.
I think I can see one there. Oh, there you
go. So here, just with my filtering, I can filter out different access points. I can choose a list of only the APs that match AP45E, and I could grab this access point here. So it's a little bit lower gain. I grab this access point, and I may decide to put access points along the ceiling in the center, right? So this gives me 3 access points. And if everything was perfectly average, I have about 100 clients connecting to a 5 gig radio. But because this AP supports 6 gigahertz, And you can use external antennas in some countries that that is allowed, especially with the AP45E and their antenna combinations. I could mount this on the ceiling and have it directed down towards the ground, right? Or I could highlight all these access points and quickly delete them. Delete these access points. I could choose another access point. Right, with higher gain antennas, and I could mount it along the walls. Just go to none for a moment. Right. And then the really cool thing with Ekahau is we can click on these access points themselves. And we can edit this access point. And by default, it wants to place it on the wall, but I could adjust it to be a ceiling mounted access point if I wanted. But I can give it some down tilt just by clicking and sliding on this arrow, or I could type in the tilt that I wanted, right? So I may want to be very aggressive and add -40 down tilt to this access point. And I can also align the antennas to point in towards the room, right? So I can have them pointing to where students are sitting in the seats, and I could adjust each of these access points. I can adjust them individually, or I could highlight groups of access points and adjust the antenna orientation in bulk. All right, so both rotating it around the room or adjusting the down tilt or up tilt as the antennas as required, ultimately giving the coverage that I'm looking for and adding the capacity that I'm desiring in this room, so that I can cover and provide the limited number of clients per radio, such that I have sufficient bandwidth to handle what the expectations are in this room. And the smaller the cell I create, the greater opportunity I'll have for clients to roam naturally on their own. If I create really small cells, as they walk towards the front of the classroom for those keen students, they'll naturally hit that -70 threshold, start scanning for another AP to roam to, and then reconnect to an AP closer to the front of the room. So I can leverage natural roaming behavior of my clients if I position the APs in the correct locations and set the size of their cells, knowing the roaming behavior of my most important LCMI type clients in my environment.
Troy, that was a fantastic demo. And if you have enjoyed watching Troy give that demo of designing for a high capacity, high density area, he's only really scratching the surface quickly on this webinar. We actually have dedicated ECSE training where we can spend 4 days talking Wi-Fi, playing with the Ekahau tools, and getting fully up to speed with how Wi-Fi works, how to optimize, design, survey your network. So we have 3 different classes that we offer, which are broken down into ECSE Design, we have our advanced class, and we have our troubleshooting class. These can be virtual or they can be in person. If you head over to that link, ekahau.com/training, you can check to see what schedule suits your time and your needs. And we're also running a little bit of a promotion at the moment. So if you sign up to an Ekahau ECSE class before 15th of September 2023, we'll be giving you a free gift card up to $25 to go and pick anything you want from the swag store. I see lots of comments in the chat asking about this t-shirt and other t-shirts and stuff like that. Here, you can go and grab one from the swag store. And actually, on the topic of t-shirts, we need your help. So, I was smiling because I saw a lot of people talking about this in the chat earlier when Troy says that he's inspiring the next generation, and what people wondering what he's doing and what they're going to be doing when they grow up, and potentially. So we are going to be designing a new t-shirt, and we want your help. These are some of the expressions that we're familiar with when doing a site survey with the psychic. But Mac, maybe if you read them out, I'll launch a poll question, and people can vote for their favorite expression.
Of course, I'm sure that most of us, we've been through that, right? Especially when you go and survey a financial institution, it's like that they seem to have a lot of jokes. Okay, so no, I am not ghost busting. No, I'm not trying to catch Pokemon. No, I'm not selling ice cream. No, I'm not spying on you. No, I'm not scanning your credit card. Don't mind me, I'm just here to optimize your Wi-Fi. And if there is something else, so let us know in the chat. There are some options in the chat, actually, but it's so fast. So fast. Checking for VPNs. Yeah.
I'm not Starlink. That could work quite well for me potentially as well.
Don't mind the tinfoil hat. I do wireless for food.
Hilarious. Okay, let me share the results, because that actually there seems to be a clear winner here from the poll question anyway. So don't mind me. I am just here to optimize your Wi-Fi. I think that's a great expression. So keep your eyes peeled. You may see a new design of a Ekahau t-shirt sometime in the near future where we will have that expression. And I just want to let everyone know that we still have a little bit of content to get through today, so we may run over a few minutes. So if you want to stay with us over the past the top of the hour, you're more than welcome to stay. So just to give you a little bit of a heads up, we'll probably be a couple minutes over the scheduled slot today. But Mac, network configuration then for Wi-Fi and education.
Guys, have you noticed that all the slides that I'm covering today is like nice AI created photos with no real content? Okay, so network configuration it's super broad, guys. Network configuration for education is like, what frequency bands are you using? How are you configuring for roaming? Do you enable all the amendments like 8.11k, for example? Do your clients excuse me, do your clients support it? Do you use radius in the backend? If you do you enable 8.11r? So every time your clients roam, they don't have to go through full radius authentication. If you're using something like EduRoam, what frequency bands is EduRoam sitting on? Can you make it 5 gigs only? Hint, no. And many other things like channel widths. Can you have 40 or 80 megahertz without excessive CCI? Most likely not. How about the transmitting power levels? Should it be sitting on minimum or maximum or anywhere in the middle? Hint, probably in the middle. And yeah, many more considerations like that. So Troy will dive a little bit deeper into the network configuration, but it's a lot to think about.
I saw this the other day and it just made me laugh, because I've actually been speaking to some friends recently who have been trying to set up a few wireless networks, and I'm sure everyone can relate here about captive portals. I mean, I get it. I know the people want to have them still, and I can understand the reason why, accepting those terms and conditions that everybody reads, or filling out that really long capture form of all of that information that we've got to share with people. But the thing that just kills me is the inconsistency of the experience of the captive portal across different devices. One day it works great on your iPhone and your Mac and your Windows laptop, but on your Android phone, you don't get presented with it. You manage to fix that, get that sorted. A week later, there's a software update, and all of a sudden now it's not being presented on your iPhone, and all the other devices work completely fine. It's just frustrating. So yeah, I saw this, it made me laugh. I hope it made a few of you smile on here as well, that you related to a few of these things. But Troy, maybe you can just share a little bit of your expertise and some other things to think about when it comes to the education network configuration.
Yeah, absolutely. So in the education space, if we think on the wireless side of things, we always want to be mindful of the SSIDs, keeping the total number of SSIDs relatively low. Good practice is not to exceed more than 4 SSIDs if you can. But with the higher minimum basic rates, it's becoming less of an issue, right? You really start to see that those challenges present themselves in those higher density environments. We're trying to squeak every percentage of airtime performance out of your networks. But in a lot of K-12 schools with appropriate minimum basic rates, it's not as much of an issue. EduRoam is a fantastic service and technology that provides essentially universal access across a lot of higher education institutions. So you want to make sure that you provide support for EduRoam while also taking into account client capabilities that we discussed earlier. That can vary from year to year and even season to season as new devices get introduced to your wireless networks. We talked earlier about backhaul, the size of your WAN pipes, making sure that it's sized appropriately. When you start running through your capacity design exercises, make sure that the capacity that you're designing your Wi-Fi network matches what's in your backhaul pipe. Take a look at your WAN traffic. Right? See what's actually being passed across that wireless network or through your controller via your cloud management dashboard. See what network's currently being used and what you need to scale for, right? So that you're designing for reality, not just pencil and paper exercises. A lot of problems I see a lot of K-12 schools run into is DHCP issues, right? All of a sudden, new school year starts, and a lot more students have brought in devices where now they're looking at one-to-one student-to-device ratios, all grabbing IP addresses, or they have a student event in the evening where a lot of parents or visitors from the community show up and they connect to the guest wireless network and they consume all the DHCP addresses, right? So there's a lot of different options you have for solving these problems. You can increase the size of your subnet mask if that's an option, or you can do VLAN pooling or similar concepts if your vendor implementation supports that, because you don't have the ability to change the subnet size of your VLANs. So lots of different ways you can address that issue, but something you definitely want to take into account because it really frustrates users. On their client device, the Wi-Fi logo lights up and it looks like they're connected to the network, but they don't realize what's missing is they don't have an IP address. All they know is that they can't update TikTok to send images of their son or daughter performing in the school band while on stage, right? And so they get quite frustrated. And then the last point applies much more to the dorm room environment, right? A lot of dorms are being deployed with 1 AP per dorm room, right? So excessive Wi-Fi radios that you may need to turn off, but we're deploying them there so that we can create private or community-based VLANs. And this allows students to go into their dorm room, plug in devices, gaming consoles, printers, their lava lamps, whatever they need in their dorm rooms, and only students within that dorm room have wired access to that VLAN, right? So it's a self-contained private VLAN local to just them, where they can still walk around and roam wirelessly across the network and still have Wi-Fi access across the entire dorm, but it's limited, controlled, filtered access just for devices in their dorm room. And that's something to think about beyond just the Wi-Fi layers, right? So it's deeper into the network, how you're going to design and plan for that. So a lot of great considerations to think about more than just Wi-Fi when you're building networks, especially in higher education environments.
Yeah, and the frustrating thing that everyone on the webinar today can definitely relate to, no matter if you've designed the perfect wireless network, it's just been fully optimized and the wireless is spotless, you have an issue with one of those last three bubbles, the backhaul DHCP or something through the VLANs or something else through the network. You know, whenever someone complains, it's not going to be them saying, that DHCP scope hasn't been scoped correctly. It's going to be, nope, the Wi-Fi sucks here, doesn't it? So we all know the impact of making sure the rest of the network is fully prepared, configured accurately, has a big conception of how the perceived performance of the wireless network is going to be. So yeah, great insight there, Troy. Thank you very much. And one of the last slides we just wanted to show you is it's always nice when we're talking about the specific vertical and environment education is you can see some of our education customers using our tools in the field and their real feedback. So using Ekahau AI Pro with the psychics made their life so much easier with the setup of the infrastructure and optimization. So really great feedback there. And if you enjoy our Ekahau webinars, you can sign up for our next webinar, which is all going to be about, that's about as far back as I can go. I'm not quite like the guy in the graphic there. My back might go out if I try and go a little bit further, but we'll be covering the Wi-Fi fundamentals, navigating the matrix of wireless. And I wonder if you'll be taking the red pill or the blue pill at the end of next week's next webinar. So you can scan the QR code and sign up and get access to our next webinar.
What's the name of that guy that does this? Like, you know, whatever you've done.
Neo, are you telling me you've never seen this?
I have.
Okay.
Checking your knowledge.
Yeah. Oh no, don't worry. My matrix knowledge is okay. I think we'll see on the next webinar. But I'll stop the share now, so hopefully everyone's had a chance to scan the QR code. I know there's been loads of great chat in the chat today and questions in the Q&A. So we'll bring back our favorite psychic Stu, and we may just answer a couple of questions. I know we've gone a little bit over today, but I know everyone loves this part as well. So we'll see if we can squeeze in a few questions for our special guest.
Yes, hang on. Let's go right back up to the top. One of the biggest ones that one of the biggest one of the main questions we've seen is designing for those auditoriums, and you kind of covered that there, is talking about the cell size, and I think that's really, really important, is to have folks understand that it's not about would you agree, is that it's kind of, it's not about the bandwidth, right? It's about the efficiency of that bandwidth, because it seems that some customers saying, hey, should I be having bigger throughput on the back end of my APs to the switch? Does that make a big difference? And that seems to be the big question here. Is there, you're talking about it, but the internet and what and not as well. But that seems to be the question. Do I need to worry about, when I'm with the 2.45 and our 6 gigahertz now coming, do I need to worry about that throughput on the AP?
Yeah, I think there's 2 points of bottleneck, right? You have a wireless airtime bottleneck, and then you have a bottleneck on your wired infrastructure between the access point to your switch to your controller on the wired side, right? More often than not, the biggest bottleneck ends up being the airtime on the wireless side of things, right? Once you've addressed that, and you're actually pushing more than a gig of sustained throughput, then I would start looking at upgrading to 2.5, 5 gigs on the wired side. But first, I'd focus on making sure that I can provide enough capacity on the wireless side, and we can model that within Ekahau to simulate and visualize how much RF capacity we're providing. Common rule of thumb that I use is the only way to add more capacity is to add more radios. Right now, whenever you give a rule of thumb in Wi-Fi, there's always certain caveats. A lot of these rules are meant to be bent, or if not broken, right? But as long as you can manage channel reuse, right, and you've applied the appropriate number of spatial streams and again, the channel width, and as long as you can get clients to roam between the access points, then you're doing a very effective job of managing your airtime. If you get a lot of clients that all kind of congregate on one access point, as every student walks through the main doors, all their client devices are going to prefer that first access point that they hear the loudest. That's what the roaming algorithms will do. And if you look on your wireless management dashboard and you see a lot of client devices congregating on one AP with very few on another access point, you know that you have a stickiness situation, right? So either you can solve that configuration-wise using load balancing, or you need to do a better job controlling the cell size of your access points to hit those natural roaming boundaries, which will encourage and incentivize clients to roam naturally as they move from the back to the front of the classroom or auditorium.
And I guess a great way to visualize this, no product placement here, but I mean, using the Sidekick too, to kind of visualize that, to describe that to the customer, right? And to the clients, hey, this is what's happening. You can see it here from that RF, right? So as then the product placed with it, but is using a tool such as the Sidekick to figure that out, right? This is the only way to really visualize it, the real effects of hitting that AP as soon as you come into the front door. That seems to be a common one. So is it, have the AP maybe on the outside of the door, right? Bringing clients in and then transition down the hallway.
Mm-hmm.
A lot of the questions that you covered that were asked, we did get a lot of that during the actual session, and I think that really flowed through nicely. Definitely a lot on type of placements, APs under seats and whatnot. Obviously, education is a mixed bag of things, right? You would agree. There's a ton of things out there that you could be configuring for. There's a ton of different use cases. Matt listed, on walkways and campuses, not all depend on making sure that clients are connecting, right? So I would say that you would probably say that education is a very special environment, so to speak, as opposed to like industrial and whatnot. But it seems to have everything.
Oh, definitely.
Yeah, exactly. Well, I think we mentioned in one of the slides, only a bit of a microcosm of everything. So challenging environments, large public venue, outdoor, high density, supporting older devices, hospitality as well, like catering for people to dorm rooms and stuff like that. You get a real mixed bag. But I mean, what a great environment to learn and cut your teeth around Wi-Fi, going around and doing education wireless networks, because you get to see just a bit of everything and get to be creative. So that's where I suppose Troy has such amazing knowledge around this subject, and especially Wi-Fi. So yeah, thank you very much for sharing that, Troy.